Okay, here we are given an image of a student touching the dome of a Van de Graaff generator, and we are told that the dome is negatively charged, and we're asked to explain why the student's hair stands up on end. So we're already told, as I say, that the dome is negatively charged. Now, because the student is in contact with that, what that means is that the negatively charged electrons on the dome will be transferred to the student. And because those electrons have been transferred to the student, that means that the student and her hair is negatively charged. Now, because each strand of hair is negatively charged, we then have to think about the way that charges interact, and we know that like charges are going to repel. So each of her hair is negatively charged, and they will repel each other, and that's what causes her hair to stand on end. So the Van de Graaff dome creates an electric field, and we're asked to define what is meant by an electric field. So a field is a region around a charged object, in this case, and in that region, other charges will experience a force. And as you move further away from the dome, the field strength is going to decrease. So now we're told that when the earth conductor is put near the dome, there is a spark, and we're told how much energy that spark actually transfers and the charge that is transferred at the time, and we're asked to calculate the potential difference. So we need to go to our formula sheet where we will find the equation for potential difference, and that equation is V is equal to E over Q. Now we can see that our energy is 0.6 joules, but we've also got a charge here of 2 microcoulombs. So once again, you have to spot the prefix here. 1 microcoulomb is equal to 1 millionth of a coulomb. So 1 microcoulomb is equal to 1 times 10 to the minus 6 coulombs. And therefore 2 microcoulombs is equal to 2 times 10 to the 6 coulombs. So when we plug those values back in, we have 0.6 divided by 2 times 10 to the minus 6, and that gives us a value for PD of 300,000 volts. And then we're asked finally, which of the following would increase the distance a spark can jump? Now, a spark is just a moving charge, and remember, moving charge is current. So what we're saying here is which of these would actually allow a current to flow faster? And the answer is therefore decreased electrical resistance, because resistance obstructs the flow of current. So if we have less resistance, the current can flow more easily.